Welcome to the third video of the Cupertino Robotics Project CNC. In this case, we're going to revisit the hole with a slot in a block, the very simple one, and we're going to use a different milling technique, which is called HSM, high-speed milling. The approximate runtime for the design and the video and showing the machining is about 20 minutes. Let's see how we could use CAM to control our Tormach 770M CNC mill. This continues our discussion of the simple block, quarter-inch hole in it, and a slot down the middle. I want to show you a little bit different thing, a few different things we need to do in a CAM software in order to really do a nice job on this. So the first thing I'm going to do is, so this is already done. You don't have to watch me try to design it. I'm going to go to Solidworks CAM. I'm going over here to pick up the CAM tree here, and then we're going to configure. Okay, so it looks like the mill's good. The tool crib, we have to select this and make sure you don't forget to check this little box here. Okay, that looks good. We don't have a post processor, so we can flip this guy up and we're there. Okay, let's see what our stock manager says. It's the same thing we've done before. The stock manager says it looks good. I'm going to make it out of high density polyethylene, and then I'm just going to finish that up. Now let's get our coordinate system. Coordinate system, we're going to use the stock bounding box vertex as we did before. Put our coordinate system up here. Of course, the Y and the Z, as we talked about before, have been flipped around. So I have to go into one of them. Let's say I just pick the Y, and then I want the Y to run on this. And I got to flip it around. So now it's in the right position when I put this in the upper left-hand corner of the part in the mill. So we have that part there. Okay, so we're good. Setup, of course, the setup, because of the coordinate system I used in SolidWorks, is always trying to do the front plane. So I want to do this plane, and then I have it here. So this is where we had it before. We're all ready to do. If I extract the parts, there it is. I have the rectangular slot showing here, and then I have the hole showing here. Now we're going to generate the plan. and generate the plan. Looks like this. Now, I'm going to do something a little bit different on this one. I'm going to use a different method of doing the machining. And so I'm going to take this rough mill and I'm going to delete it. Okay, I don't want that rough mill anymore. And then, so I have a rough mill, I have the contour mill, and then I have the drill. I might as well get rid of this while I'm thinking about it. Okay, I don't want to recycle it, I want to get rid of it. Okay, now I want to go into this mill and I want to look at some features. So I'm going to right click on here and then I'm going to look at the mill, a couple of things. The 2.5 axis mill operations, but before I do that I want to do the edit definitions. Okay, so I'm going to edit the definition. Okay, and the edit the definition has a whole bunch of stuff about how I'm going to do that mill. Notice we're using this 1/8 inch flat end mill. Okay, it's for rough and finishing. Okay, and it has a whole bunch of stuff about the tools that we're using. So this is everything we know about that tool. Then we're going to look at feed and speeds. Okay, the feed and speeds on this thing is determined by the library, and this says that it's going to have a surface speed. The tool, as it rubs against the aluminum, is going to have a surface speed of 328 feet per minute, okay, which is fast. Spindle speed's going to be at about 10,000. And then we have a bunch of these things about the X and Y feed rate, and Z feed rate, and all these things. That's how fast it moves through the material. Now I'm going to look at roughing, and it says it's going to have this pattern, which is that kind of stayed pattern that we had before in the previous example. Nice straight lines and these kinds of things. I'm going to change that. And I'm going to use something that's called high-speed milling, or HSM. And in this case, I do it by using volume milling. So I click on volume milling, and look what it just did. This is the path of that mill as it goes around and around. And notice what it's doing is it's doing it in kind of a circular motion, and it's doing that to make sure that mill does not get that the edge of the mill is constantly in contact with the part in just one simple straight line. So it makes it much simpler for the mill. The step over is basically how far we want those lines to overlap, and I'm going to do the step over as 10, which basically says that there's not going to be a lot of overlapping with this thing. I want to go in here one more step to show you something. I'm going to bring that definition back up, and then I want to look at the numeric control. Here's the feed and the speeds, and the feed and the speeds have changed. The feed rate is much higher now than it used to be. So here's the roughing, okay, and here's the depth parameters. I want to make this so that the first cut is a very small cut, okay, and I want to make that 0.05, so 50 thousandths, okay, on that, because I don't want to break that mill in. Okay, an 1/8 inch mill is a very small mill. Let me just do one more thing. I keep on hitting enter and it flips that configuration up. So I'm going to make one more manual change on this thing. And so the step over, the allowance, okay, is there. It's volume mill. And I'm going to set this allowance to 0. Okay, which says it's going to mill right up against the edge. Actually, no, let me go back. I'm going to, because I'm going to do a contour mill after it, that will clean that up. So the allowance I'm going to set as 0.01. Okay, so that'd be 10 thousandths. Okay, on there. So I'm not going to cut all the way up against this edge because the contour mill will do that. Okay, so I think I have that. Let's generate the tool path on it. Notice it's taken a little bit longer to generate the tool path now, but it will happen. There it is. Now notice the tool path. It's far more involved than it was before. It's not this nice straight lines going back and forth as we had before. It's a bunch of these curly things that we've talked about before. Okay, so that looks good. Let's simulate it and see what's going to happen. So I'm going to simulate my tool path, and I'm going to run it at low speed to start with, but then I'm going to have to speed it up because it's going to take forever. Now notice what happens. See how it is going in and making little kind of arcs, little half moons in there, instead of trying to run straight into it. And as a consequence of those little half moons, it means that the amount of force that's being put on the mill or the mill tool is much less. So I can speed it up a wee bit. And speed it up a wee bit. And there it goes. So do you see how it's going into it with this nice rounding? And that puts a lot less force on the mill and on the mill tool, the mill end, and it also makes it cut a lot cleaner. So let's see, we're going to have to probably have about 4 passes on this one. So we'll let this thing go. So there's the first cut. So we just cut 50 thousandths off of it. We're going back, clean it up a little bit. Now we're cutting a little bit deeper. And notice how it cuts both sides to get it started. And so there goes. So this is 100 thousandths, and I think we want to go to 200 thousandths on this. So we're about we're pushing it halfway. And yes, it is boring to watch it after a while. It looks a lot like watching a 3D printer. Let me see if I can speed it up a little bit. There it goes. Okay. Now that's going really fast. Okay. There it's doing the it's continuing. Cleaning up the edges, the sides, and then it just did the contour and then it finished. So we look at that, and now we can look at the tool path if we want to step through it, but it's basically going to give us about the same thing we had before. So it's just going to step through one piece at a time. And I think you'll see it's the same thing as we had before. So I might as well give up on this. Okay. And then we're going to do the post-processing. And so let's see what this thing is called Simple Hole with Slot. And then I'm going to do high speed, milling. Okay, so we're saving this. Here we go as we process it. Now notice how much more processing there is because there's many more steps in this thing. Again, the purpose of high-speed milling is to be able to get a great cut and yet not break the mill end on this thing. And so it's well worth it. And as a matter of fact, I think we will only use high-speed milling for many of the applications that we do. Okay, so let's see. Well, that generated about 200,000 bytes. Okay, so let's see what it looks like. We'll bring it up here, and here's the deal. Okay, so it's a lot more complicated. Okay, you can't, I suspect you can't look at this G code and say, what is it that it's actually doing and why is it doing. So this is kind of between the CAM software and the mill, the CNC mill. We can go down a little bit if I can, but it's probably not worth it. Let's see. Let me go down to the bottom and see what I find. Okay, here's the drill. So we know what that thing is. It picks up the drill and it goes down. And then we go up here and we could probably fairly quickly see the contour mill. So here's where it cleans up that slot. And the 7100 statements before, above that, is where it uses the high-speed milling to cut that rough slot. Okay, so I hope you found this a little bit interesting as we start talking about different ways of controlling the mill in order to get a better finish, and at the same time we're much less demanding on the mill ends. So that finishes this discussion. It takes about 15 minutes to mill the slot, and so rather than watch the whole thing, I decided to join the mill during the final pass where it's cutting the last layer of that slot. So it's cutting a little 50,000th of an inch layer off of it. See the high-speed milling where you have that circular motion, and that puts a lot less force on the mill end. I sped it up because I got bored, and this is actually the speed that you could actually see a mill running if it were running with the high speed parameters. But I wanted to run ours slower, so we put less stress on the tools and on the material. So here we are, we're just about exiting that last piece, or that last layer, and you'll see it as it runs through there, and it's going to come back and it's going to finish the walls. Yes. Notice it goes back and cleans up the edge, and it finishes the wall, and we're still in rough milling. Each pass brings the wall down 50 thousandths of an inch. We're done with the rough milling. Now we do the contour milling. And remember, this is all just to make that a really nice finish on the side. Sped it up again because I don't want to bore you, but it keeps on putting it down. And here's the final pass. Okay, the program's paused and asked us to do a tool change. We are taking out the 1/8 inch mill, tool 1, in our tool crib, and we're replacing it with tool 45, which is that 250 thousandths drill. And so we're loading it up, and we should start pretty soon. Coming down. Remember, look at the pecking. It goes in a little bit and comes out, and as it comes out, it's bringing all the chips out of there, all the little pieces of polyethylene. Gives us a much better hole doing it that way. And I think we have the part fixed. Bye.